Hello students, today let us prove one theorem from the topic triangles of class 9th. And the property is about sum of any two sides of a triangle. The statement of the theorem is the sum of any two sides of a triangle is greater than the third side. We have to prove this. For that, let us have a diagram. So in this one, triangle ABC is given. So here triangle ABC is given to be any triangle. We have to prove that if we consider any two sides of this triangle and if we add the lengths of those, it must be greater than the third one. So that is, we have to prove that if we consider AB and AC and if we add the lengths of these two sides, it must be greater than the third side, that is, it must be greater than BC. So this is the first statement we should prove. AB plus AC must be greater than BC. Now secondly, if we consider AB and BC, these are the two sides, then AB plus BC must be greater than the third side AC. And we have another pair of sides AC and BC. If we consider these two sides and if we add these two sides, this AC plus BC, its sum must be greater than the third side AB. So these are the three statements we have to prove. So for that one, we have to do one construction. We have to extend ray BA, and on that ray we have to take point D such that AD must be equal to BC. And then we have to join points D and C. So this is the construction we have to do. Now let us have the proof. By doing this construction, we have got a triangle ACD. For this triangle, AC is equal to AD, as we have taken any point D on ray BA such that AD is congruent to AC. This is because of the construction. And we know that if in a triangle two sides are congruent, then angles opposite to them are also congruent. So angle opposite to side AD is angle ACD, and angle opposite to side AC is angle ADC. And here these two sides are congruent. That's why angle ACD is congruent to angle ADC. And this is because the isosceles triangle theorem. Because by isosceles triangle theorem, if two sides of a triangle are congruent, then the angles opposite to them are also congruent. So this is what we get. Angle ACD is congruent to angle ADC. So this is the equation we have. The measures of angle ACD and angle ADC are congruent. Suppose if we add something to the left hand side of this equation, that is, if we add angle ACB to the left hand side, the relation of the equality will not be there. That means then in that case the left hand side will be greater. That is, angle ACD plus angle ACB must be greater than angle ADC. So this is the relation we get. Now if we see in the diagram, angle ACB and angle ACB, if we add these two angles, we get angle BCD. So here angle BCD is greater than angle ADC. For triangle BCD, we have proved here that measure of angle BCD is greater than measure of angle ADC. Now for angle ADC, we can also name it as angle BDC. And we have proved that in any triangle, if two angles are not congruent, then side opposite to greater angle is greater than side opposite to smaller angle. For angle BCD, we have proved here that angle BCD is greater than angle BDC. That's why side opposite to angle BCD must be greater than side opposite to angle BDC. Here side opposite to angle BCD is BD. That's why BD must be greater than C, and the side opposite to angle BDC is BC. That's why we have this relation, side BD is greater than side BC. The reason is side opposite to greater angle is greater. Now see in the diagram what is BD. Segment, we get segment BD if we add two smaller segments BA and AD. Is instead of BD we can write BA plus AD, which is greater than BC. We have replaced here BD by BA plus AD. As B, A and D are collinear points, that's why we can split BD into BA plus AD. Now we have proved here AC is equal to AD. So in this equation, instead of AD we can write AC to get BA plus AC is greater than BC. As AD is equal to AC, that we have already proved here. Now if we rearrange this, we get BA as AB plus AC which is greater than BC. So here we have proved the first statement that we are asked to prove. Similarly, we can prove the remaining two results, that is AB plus BC is greater than AC and BC plus AC is greater than AB. So in the same way, all these three statements can be proved. Hence the theorem, the sum of any two sides of a triangle is greater than the third side of the triangle.